Hello and welcome to this episode of Math with Martinez. In this video, we are looking at the famed unit circle. This is in our unit in pre-calculus, Unit 8, titled Trigonometric Functions. So let's go ahead and dive on in. The unit circle is illustrated here in the margin, and it is a circle whose radius is 1 unit. This circle is often depicted in our coordinate plane, and the points along the circumference will be denoted with X and Y, and that X and Y actually correspond with our trig functions down here below. If you'll look at this with me, you will see how and why this relationship exists. Remember that sine, if you think back, and I'll write it up here at the top, sine is, or in the margin, I'll do it in the margin. Sine is the opposite over the hypotenuse. So in our diagram right here, if this is our angle, then the opposite is this side. That side is the y, or the height of our point, and then the hypotenuse is 1. So that means that sine is the y over 1, or simply just the y value. So whenever you're looking at the y value of that coordinate, that is actually the sine of theta. Cosine, remember this, that cosine is the adjacent over the hypotenuse. So adjacent to our theta is this side right here. Adjacent to this angle is this side, which is the x, the distance that we have moved x to get to our point x. So again, it's the adjacent, or x, over our hypotenuse, which is 1. So it just simplifies to x. So in this diagram, if you have a point on the circumference of your unit circle, the x actually corresponds to cosine of theta. And last but not least, your tangent. Remember that tangent is the opposite over the adjacent, which is going to be the y value over the x value. So in the unit circle, because your radius is 1, these simplify really nicely. Furthermore, the reciprocal functions are just 1 over the value of its reciprocal. So cosecant is 1 over y, secant is 1 over x, and cotangent would be your x over y. And so what all this says, all of this concludes with the big idea that the coordinate P can be, instead of written as xy, right? We know that it is x comma y, but that could also be stated as cosine of theta, sine of theta. So that point xy is the same thing as cosine. So now, with that in mind, with the fact that the coordinates on the circumference of our unit circle are cosine and sine, we're going to connect this with what we learned in our previous unit about our special angles and see how that and the unit circle are going to now come together. In your unit circle, all the special angles are listed here. And what I want to show you is the relationship that exists. So 30 degrees is one of our special angles. Remember that? And if I draw the diameter here, you'll see that in the third quadrant, the angle that corresponds with that is 210. Now, why exactly is that? That is because the 30-degree angle here in quadrant 1, if you're thinking about that, well, the reference angle right here, those are the same. If you look at 210 its reference angle, that distance between that terminal side and the x-axis, is 30 degrees. So those are corresponding triangles. They also, if you look here, these are going to be also angles in our unit circle that have a reference angle of 30. 150 and 330 are also angles whose reference angle is 30. Now let's see, there are a few more. 45 is one of our special angles, and in the other quadrants, you'll find that there are angles whose reference angle is also 45. And lastly but not least, 60 is one of our special angles. And there are actually 4 angles, one in each of our quadrants, that have the reference angle of 60. So why do I emphasize this? Because we can find sine and cosine of our special angles. And because we can find sine and cosine of our special angles, we can find sine and cosine for all of these angles because they share the same reference angle. So check this out with me. You all recall that for a 30-degree angle, the cosine of that, cosine is going to be square root of 3 over 2, and sine is 1 over 2. Now that is going to be the same for all of those triangles or angles that I've marked in green, because they all are actually the same angle for the reference angle. They're just located in different quadrants. And because they're located in different quadrants, check this out. There's only one small little change that we have to account for. Remember that in quadrant 2, the values that are negative are the x values. So for every single one of these angles in quadrant 2, the x is negative. And in quadrant 3, both x and y are negative. So I'm going to just go ahead and set these up right here. And in quadrant 4, it's the y values that are negative. So there we go. That means that we know sine and cosine for 150, for 210, and for 330. They are almost exactly the same as 30, which you see in quadrant 1. The only difference is that the signs, the positive, might transition to a negative because of the x or y values in that quadrant being positive or negative. So take a look at 45, which is the same thing as pi over 4. Remember that for 45, sine and cosine are square root of 2 over 2, which means for all of those angles that are highlighted with pink, the sine and cosine, the x, which is cosine, and the y, which is sine, they're all square root 2 over 2. But in quadrant 2, the x value, the cosine, is negative. In quadrant 3, the cosine and sine, both of them are negative because x and y are always negative here. And then in this quadrant, it's only the y value or the sine value that's negative. All right, we're just about done here. Now let's look at 60 degrees. With your little hand trick, you'll recall that cosine is 1/2 for 60, and the sine is square root 3 over 2. So that's going to be true here, except my 1/2 is negative. In quadrant 3, both are going to be negative. And in quadrant 4, it's just Ooh, sorry, my square root got funny. It's just the square root of 3 over 2, the y value, that's negative. All right, so that's just about all. There's just 4 more coordinates that are missing, and those are probably the easiest to find because what we're doing is we're focusing right here on this point, which is a distance of, yep, that's the radius. So what is the x value right there? How far away from the center? Well, remember, this is a unit circle, which means it is 1 unit away from there. So that is the point 1, 0. Up here, this point is 1 unit away from the origin. So the x value there is 0 and the y value is 1. On the other side over here, we have the coordinate -1, 0. This is the point -1, 0 because it's 1 unit to the left. And then down here we have the point where the x is 0 and the y value is a -1. So there we go. We have populated our unit circle, and we've kept in mind these big ideas that in quadrant 1, remember all of these angles, sine, cosine, and the reciprocals, tangent and its reciprocal, they would all be positive. In quadrant 2, the only ones that are positive are sine, the y values, and the reciprocals. The only thing that's going to ever be positive in this quadrant is if you take and look at the tangent or cotangent. And in quadrant 4, it's the cosine, the x values, or the reciprocals that are going to be positive. Again, just to summarize what we said at the top of the page, sine is y, cosine is x, and tangent is the ratio of those two. And these are the reciprocals. All we've done is take and flip those initial function ratios. That's it for our unit circle video. If you guys had any questions, please take a moment to share those now. And until next time, stay fired up.